Hi everybody. One of the problems that we skipped in class on on Monday, because we were running a little bit short on time, was this Carnival ticket problem. So I'm going to work that through with you now. Carnival usually sells 3,000 tickets at 75 cents a piece on a typical Saturday. Now they can raise the price, but of course they're going to lose some customers. So for each 15-cent increase in price, the management figures they're going to lose 80 ticket sales. So the question is, how much should the price be raised to end up with $2,982 in revenue on a particular Saturday? So just to make sure that the problem is clear, if we do one ticket price increase, that would mean we're going to increase our ticket price by 15 cents. Okay, so each ticket price increase is 15 cents. And if we increase the ticket price one time, our new price will be 90 cents per ticket, but of course we're going to lose 80 ticket sales because of that. All right. Well, what we want to do is we want to figure out exactly how many times we should increase the ticket price so that we end up with $2,982 in revenue. Well, here's what we know. The total amount of revenue can be found by multiplying the number of tickets sold by the price per ticket. So currently we have 3,000 tickets sold at 75 cents a piece. If we start raising the price, this is going to change a little bit. For starters, we have 3,000 tickets sold, but we're going to lose 80 ticket sales for each N. That is to say, we're going to let N be the number of price increases. When N equals 1, that would mean we're going to have one ticket price increase like we said up here. 2 would be a 30% increase, and we'd lose 160 customers. Now our total revenue is going to be 3,000 minus 80 tickets for each increase that we allow to happen. And the price per ticket is going to be 75 cents plus an extra 15 cents for each ticket price increase. So 0.75 plus 0.15 times the number of ticket price increases. So there's our total revenue function. If N equals 0, that is to say if we don't raise the price at all, it'll simply be 3,000 times 75 cents. Now we want our total revenue to be $2,982. So there's our equation. 2,982 is equal to 3,000 minus 80N times 0.75 plus 0.15N. There's our quadratic. That's what we need to solve. Now we can clean that up a little bit. Let's FOIL out or multiply out the right side of this equation. 3,000 times 0.75 is 2,250. 3,000 times 0.15 is 450N. Negative 80N times 0.75 is negative 60N. And 0.15N times negative 80N is negative 12N squared. Now you can do a certain amount of rearranging there, but I think you'll agree that after you do some rearranging you'll end up with 0 equals negative 12n squared plus 390n minus 732. And now you can see that we've got a quadratic in standard form. Now we can do better than this if we want to. We could divide everything by a negative 2, but we can also just use the quadratic formula here. A equals negative 12, B equals 390, and C equals negative 732. So at this point you can use the quadratic formula. X will be equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And we'll end up with two solutions here. X will be equal to 2 or 30.5. So that means we can either raise the ticket price 2 times, or we can raise the ticket price 30.5 times. It's kind of hard to raise the ticket price a half a time, but if we raise the ticket price 2 times, that means we're going to bump it 15 cents on 2 separate occasions, and so our new ticket price would be 75 cents plus 2 15-cent increases. $1.05 is our new ticket price. So to answer the actual question, the question was what increase in ticket price will produce that revenue? Well, the increase in ticket price was 2 increases. That is to say, it's a 30-cent increase.